Welcome to RockSim Live. I'm Tim Van Milligan, and I forgot to schedule the stream for today, so we're kind of starting in the middle. But we are starting at about 2 o'clock, so I'm on schedule. So far, because I just started the stream, there's nobody in the room. So I will go ahead and give you my introduction. I am Tim Van Milligan, as I said. This is RockSim Live, where we talk about RockSim, RockSim Pro, and the Launch Visualizer. Today is March 8th, 2024. What the heck is this button? Oh, that's OBS. Oh, we got Kevin's Models and More. We got our first customer. Well, welcome, Kevin. I forgot to start the stream, I forgot to schedule the stream. So here we are. We're at RockSim Live. And let me see. I want to start my computer here and bring up my website. Okay, so let me switch screens here. There we go. All right, so this is the Apogee website. So it's apogeerockets.com. When you come here, you'll see all kinds of good stuff. We're doing the RockSim training right now. It's called RockSim Training Live. And if you click on this image, it will take you to our archive. Now, last week, Martin was here, and he started getting into his presentation on RockSim Live, and then the stream abruptly ended. We were having some internal internet problems. I think it was not internal to the building, but local. And I was in Chicago last week. That's why I wasn't here. And I was watching his presentation, and I was like, I want to see the end of this. So we're going to try to schedule Martin to come and finish that someday, where he was talking about gathering altimeter data to figure out the coefficient of drag of a near supersonic rocket. Look, we got Stuart LaFond from Vermont. Great. So if you're checking in or if you're just joining us, go ahead and put your name in there and say where you're watching from so that we can recognize you. And so we only got 2 people in here so far. So you guys got to come up with some good questions on RockSim. I'm dependent on you. This is an audience participation session, so it's your questions that I'm here to answer. So the last time I was here was actually the 16th of February, and we talked about RockSim and the Launch Visualizer and igniters for Aerotech motors and lightweight materials. Yeah, it's all good stuff. On the Apogee website, if you want to download a free version of RockSim, you can either go to Shop or How To and Guides, but go to How To and Guides, and then come down here to Software, and then you can download the free trial right there. And this gives you, you enter your name and your email so we can send you the download link. And it tells you some of the features here and how to install. So once you download it, you'll have to install it. And the installation is just like any other software. And when you run it for the first time, it should give you the demo mode for 30 days. If not, you'll need an unlock key, and we can provide you an unlock key. Just email us and we can give you that unlock key. For some reason, for some people, the demo hasn't been starting up properly. But we can give you that unlock key, and we can, make it for 30 days so you can get your full 30 days. So I was hoping this week we were to announce the release of the next version, but my programmers they ran into some problems, some big problems. Anyway, we have to explore And it's David from Michigan, but he's in Florida now. Marcel is here. It says, I'm designing a rocket and trying to decide if 3 bigger fins is better or worse than 6 smaller fins. Okay, we can talk about that. And we have 6527 Dave. He says, I'm going to ninja listen while working. Okay, so I guess that's doing it on the slide. Maybe it's so his boss doesn't hear. All right. So great to have you all here. So if you're just starting with RockSim and you've never done it before, again, go to How-To and Guides, come down here to Software, and there is video tutorials right here. And those video tutorials will kind of walk you through it. Step number 1, getting started by opening an existing design and running a simple simulation. So basically, I've opened an existing design. You can do the file open up here. I should probably make my mouse a little bit bigger so you can see it. So that's under settings. And my computer's running slow. It doesn't like streaming. So under accessibility. Come on, wakey wakey. Display. Okay, and here's the pointer, so make the pointer bigger. All right, so that's good enough. So now you can see my pointer better. Okay, so this is, I clicked the File Open button, and normally when you first start it, it will look in a folder called Designs. And in the Design folder, you'll have a bunch of manufacturers, like here's Apogee components, here's Dynastar, Klima, Quest, there's Estes in here, Schrockets, which is a brand from Apogee. So there's a whole bunch of manufacturers you can take a look at. And to run a simple design, let me see, open up Estes and see what we got in here. We've got Big Bertha. We'll open Big Bertha. Save changes to this design? No. So here's the Big Bertha. And here's what it looks like in 3D. And I forgot to turn off my phone. It's beeping at me. My daughter is coming back home on spring break today from the University of North Texas. And I got to go pick her up from the airport after this. But I got plenty of time. So we're not in any hurry. So here's what the Big Bertha looks like in RockSim. And obviously the colors I need to change on this because having a blue base is kind of weird. So to run a simple simulation, and this might be a question that a lot of people have, is how do you pick a rocket motor for your rocket? I had somebody come into my office this week, or into our store, and they had a rocket, and they said, what motors can I use for this? And I said, well, first you find the design, like the Big Bertha, and then it's really simple. Then you just go to Prepare for Launch, which is this button right up here, which looks like the base of the rocket with 2 arrows pointing downwards to the blast deflector. So that's Prepare for Launch, and you click on that. And then you just click on Recommend the Motors. And it's going to ask you, how long is your launch rod? What motor manufacturers do you want to look at? So I could say, well, let's just look at the Estes ones. And then use the recommended conditions, and then click on that, and it's going to run. And it found 6 motors, and these are all Estes, and it tells me, so let me see where, okay, so here, this column right here is called RockSim Recommended. So 2 of the motors, it does not recommend, and then 3 of the motors, it does recommend. And then here are the motors. My columns are all messed up. So if you want to reorganize your columns, just grab the header bar and slide it over. So I can slide this one to the end. So motors loaded. I'll slide the results to the next to that. And then I'd like to have altitude. Where's my altitude? If you can't find it, what you can do is just click on the column bar up here, and you can do organize columns. So I did a right click with my mouse, organize columns, and you can say altitude at deployment. I want maximum altitude, so make sure maximum altitude is checked, and then it added that column over here. And I can turn off some of these things right here that I don't need. Okay, those are good columns. So the results, maximum altitude, I'm gonna slide over to here. Oops, one more over. This is the CP at launch. I don't really need that, so I'm gonna take that one out. Launch CP, turn that off. Optimal delay, it's always good to know. Altitude at deployment. The recommended delay. Okay, so it recommends like this motor right here, C6-3. So that would be your recommended delay. We get a velocity at deployment, and tells me that RockSim recommended that motor. So it's how easy it is to find a list of recommended motors. Just click on that recommend button, and it will find you all the motors that it would work in this rocket. Pretty simple. I like it. So that's if like you're launching your first simulation. So all these simulations ran, and if I want to get a little bit more detailed, I can rerun the simulation. So I'll select it, then do a right click, and then do load engines, because it hasn't really loaded the engines yet. So it loaded the engine, and if I spin this around, I should see the engine in the back. All right, so then I'm going to go back to prepare for launch. And this time, this is normally where you load the engine. So we have the C6-3 under flight events. We're going to deploy at max ejection delay. Some of my columns are a little short here. We have the device and the parachute under simulation controls. That looks good. Starting state, we're actually launching straight up at a 0-degree launch angle. So this is kind of like the direction of the launch angle, and this is a wheel, so it will control the launch angle like this. But I want to launch straight up. Launch conditions, I'm launching at an altitude of 700 feet, which is kind of like eastern Iowa. Got a temperature of 59 degrees, which is a little warmer than it is outside right now. And I have a custom wind of 8 miles an hour, and this is a constant wind because I have low and high wind speed set to 8 miles an hour. And then I can hit the flight profile, and it's going to rerun the simulation again. And this time, before we were at recommended motors. Now we're at the flight simulations tab. And so that's what we're seeing in this column here. So here's the C6-3. And it's an 18 millimeter diameter motor. They recommended a 3-second delay, and it's going to hit about 584 feet. And then this screen right here is kind of a two-dimensional image of the rocket. So here's the rocket sitting down here at the pad. This V shape right here, we call that the weathercocking cone. We want to see the rocket stay inside of this cone until it hits, or at least for the apogee point. So the highest point should be between these two lines. So we click the launch button. We can see the rocket's taking off, and we're still in the lines, and there's our apogee point. So this would be a good launch. Right now we're at an altitude of 460 feet, and it's still drifting downwards, and it should come back down to the ground about 413 feet downrange. So that's a pretty good launch. I would consider that one acceptable. So that gives you, more detailed information on that particular launch. Okay, let me see if there's any questions. Okay, so Mark Sell he's trying to decide 3 versus 6. To Explore says, and he's from Michigan, will RockSim 11 allow for outside subassemblies, i.e. won't need to be used inside the rocket? RockSim 11 and 10 are the same as far as subassemblies go. Subassemblies are typically used inside the rocket. So if you want to be on the outside, you use a pod. The difference is a pod can't be saved as an outside file separate from the design. So I understand what you're trying to do. I'm just trying to think, is there a way to cheat? I'll have to think about that one. That's a good question to explore. He says he's thinking about booster pods that can be built and copied on the outside. It would be nice if you could build it and save it to use on others. Yes. There is a way to do multiple instances of a RockSim. So in other words, having two copies of RockSim open at the same time. And then if you have two copies open, you can go to one design and copy a component and then go to the other one and just paste it. So that's one way of doing it. But pods, we'll talk. We'll see about that one. That's a good question. To Explore says, is range available for use in simulations? The only way I can find it is in details. So what he's saying is, can you see the range in this column here? And I can organize columns. And do we have range here? That's a really good one. And you know what? The answer is no. I don't know why we didn't have that. We could probably do it. I mean, that's something that RockSim tracks. So what he's talking about is, he runs a simulation and he opens up in the 2D flight profile. And the range is how far the rocket lands from the pad. And you can see right here is the range. So that's one way to see it. The other way is what he said is you can double click on this row and it's going to bring up a detailed report. This is what the detailed report looks like. And it's for that particular flight. And if you scroll down to the bottom, you'll get landing data. So here is the landing data, and then here is the range at landing. Yeah, that's a good idea, having range in these columns. So that's the second way you can find it. And the third way is, if you're really interested, is plot the graph. We can plot along the x-axis is time, and on the y-axis we can say range, and then clear out these rows, and click plot graph, and here is the graph. Let me make this bigger. Okay, so here's the range. And the range, it starts at 0 where my thumb is, and then it goes negative, and then it goes positive. So why is it going negative? And that's because we had wind blowing this way, and the rocket arced into the wind, so it went negative range until Apogee, and then it started coming down this way because the wind was blowing it down while the parachute was. So that's why you get this negative first and then positive. So it started going positive around 12, 14, 18 seconds into the flight. It crossed over, so it went up, took about 18 seconds to drift back over the launch pad, and then it drifted, another 30, 40 seconds further. down to 417 feet. So that's the third way to get it. So the data is there. It's just not in the place that you want it. That's a really good question. I like that one. Ron Soto. Okay, and he says he's from Florence, South Carolina. He says, for a crumple on the body tube at the top of the fins, should I sand the crumple, sand the body tube, and use 4-ounce fiberglass and epoxy about 3/4 of an inch on each side of the damage? And then he says, so a 1/5 inch wide piece of fiberglass? Yeah, that's how I do it too. This is not RockSim related. This is just a good rocketry question. So if you go to the Apogee website, go to How-To and Guides, go down to Advanced Construction Videos, and then come over here to All Videos. And so here's all the videos that we've done. And there's a video here on repairing a body tube. So I'm going to do a Command F on the Mac, Control F on Windows, and it brings up a search bar, and that will search only this page. And what I'm looking for is repair. Okay, so it's used 26 times. How to repair a fin. Okay, kinked tube. So this is the one I was looking for. So video number 363. So if you just scroll down to video 363 from August 8th, this is the technique that I use to repair, and it's fiberglass. Just basically wrapping fiberglass around the tube, kind of like, you know, putting a cast on a broken leg. It's almost exactly like putting a cast on a broken leg, although you can make it nicer looking. So yes, so Ron, yes, go for that with that. Two Explorer says, sorry, also available as a running number on RockSim screen. So basically he's talking about the range again. And what he's talking about is when you do the flight profile, there's another place that you can find it, and that is in the details. So down here in the corner, which is below my face, down here there's a button called Details, and it's below the screen so you can't see it. There it is. Details. So this button right here, click on Details, and what it's going to bring up is a list of all the details, and then we're looking at the range. So this is right now at this point in time, and our time is time 0, we're at 0 feet, and that makes sense because we're just sitting on the launch pad and it hasn't moved upwind or downwind yet. But when you hit launch, you're going to see all these numbers populate. And so here we go. So they're populating. So now we're at minus 95, 144. Now it's getting smaller. And like we said, around 18 seconds, it should cross back over to 0. So this is another place where you can find the range. So there it is. Around 18.5 seconds, it crossed over to 0. And now we're at positive range again. So that's another place that you can find the range. It's in a lot of places. That's the beauty of RockSim. All the information is like all over the place. It's just where are you looking? But it's not in this column, which is where most people look. Ron Soto says should be 1.5. I think he's talking about his fiberglass. How wide it is, maybe. Yeah, so basically he's got a kink in his tube somewhere like right here. And he's going to put a fiberglass strip around it, just wrap it around completely to strengthen that tube. It'll be stronger than the original tube. Fiberglass is much stronger. Okay, so let's go back up to Mark Sell's question. So he's got a 3-fin rocket and he wants to change it to a 6-fin. So let's take this rocket here And right now it's a 4-fin rocket, and so you can see the 4 fins there. And let's turn it to a 3-fin. So how do you do that? Go here to the rocket design components. And then we're going to come down here to the fins. I'm going to edit the fins. So I just double clicked here. And I'm going to make the screen a little smaller so you can see it. There it is. And right now it's showing 4 fins, and I can change that to 3 fins. And we've got a huge static margin here, 2.75 inches, or a static margin of 2.75, which means that this center of gravity is 2.75 times the diameter of the tube in front of the center of pressure, which is that red dot right there. We only need to be about 1, so the static margin only needs to be about 1.0. That's kind of like the rule of thumb in rocketry. And one of the ways that you can change that is by adjusting the size of the fins. So I'm going to go here to plan points, and I'm going to hit the scale button. And I'm going to scale these down. So I'm going to make them smaller than the current fin. So let's try 75%. Click OK. You can see now the fins are smaller, but they also shifted forward. So I need to go to the General tab, and I need to change the location to the base of the owning part. And now we're measuring from the bottom of the tube to where the bottom of the fin starts. And right now it's at 4.5, and I'm going to change that to 0. Hit tab, and so now we're over here. We got 3 fins, and we still have this huge margin. But before it was 2.75, now we're down to 2.2. So theoretically, we can make these fins smaller. I want to make this 3 fins. Just saying, why am I, there we go. So why am I seeing 1 fin straight up and down? Okay, I can make this fin smaller. Let's do that. I'm going to go to the plan points, and here's the shape of the fin. So I'm going to take this fin point right there. I'm going to move it forward. So I'm changing the shape of the rocket a little bit. It's not that critical. You can see I'm making it stubbier. My margin is now 1.6 instead of 2.2. So I'm getting there. I'm going to move that point right there. Okay, so now we're at marginal 0.8, so I made it a little bit too small. So let's make this fin just a little bit bigger. Getting closer. Okay, so that's like really close. We'll call it good enough. So there's my fin. And we're going to click OK. Alright, so that's what our rocket looks like now, and it's got 3 fins instead of 4. It's no longer a Big Bertha. Alright, so let's run a simulation, because we're going to do an apples to apples comparison. We still have the C6.3 loaded into it. I think I'm going to change it to a C6.5, because I want it to go a little bit. Before it was deploying on the way up, and I want to deploy it either at Apogee or on the way down. I just want to find out what the maximum altitude of this rocket could be. So let's do a flight profile and see what it looks like. And it's going to run the simulation. Still running. Okay, so here is, let me see if I can scale the image. Okay, so that's, I got more ground right now. Okay, so here's the rocket sitting on the pad, and let's launch it and see what happens. It's going up. Still going okay. It's still inside the cone, so we're fine. There was it. It looked like it ejected just a little bit early. and then it's coming down, and this time it's drifting further. Why did it drift further? Well, that's a good question. Let's see if we can figure that out. So I'm going to cancel there. So this first one had the big fins, and with the big fins it went 584 feet. With the smaller fins, because it's less dragged, so there's also 3 fins instead of 6, our maximum altitude is 732 feet, and it tells me that it did eject on the way down. So it did reach the top, and it was starting to come over the top when it popped the parachute, and it was just like really close. So I'm going to leave that alone. So that is our first simulation. I'm going to delete these other 2s just so that we don't get confused. So I'm going to highlight them, do a right click, and hit delete. And it's going to ask me if I want to delete them. I'm going to say yes. Okay, so this is the only one simulation with 3 fins and a static margin of about 1.12. And so now it's like, is 3 fins better than 6 fins? So let's see what happens when we change it to 6 fins. So we're going to go back to the rocket design components, go to the fin set, open that up. So to make this apples to apples, I got to have 6 fins that give me probably the same static margin. So my static margin is 1.12. So if I change it from 3 to 6, my static margin goes back up to 2.21. Just for grins, let's launch it with 6 fins. 6 fins of the equal size. And let's go to prepare for launch. And what I want to do is put a comment on this one here. So this is going to be 6 fins with that are same size as the original 3 fins. I just want to have that comment there so I can tell these simulations apart later. So then I'm going to do a flight profile. Let's take a look at it. It's going to run the simulation. And this time, I'm kind of cheating here. I'm looking at the simulation. It's a lower altitude. Why is it a lower altitude? Well, we went from 3 fins to 6 fins, and 2 things changed. One is the drag is greater because instead of 3 fins, we got 6 fins. So we're going to have more drag. And the other thing that changed is the weight of the rocket, because the size of the fins didn't change, but now we doubled the number. So you got to say if 1 fin weighed 2 grams, and 6 fins is going to weigh 6 grams or 12 grams. So 2 things happened, and that's why our weight, our altitude went down. And again, the arrow direction on the parachute tells me the direction the rocket was going when the parachute opened. And since the arrow is pointing down, the rocket was coming down when the parachute opened. Okay. And then if you want to see that comment, let me run the simulation here real quick. It's going to look fairly close to the last one. Okay, so then it popped out, and then it comes down. And it's closer to the pad than the 3 fin was, but it didn't go as high, so you don't expect it to drift as far either, right? Okay, so I'm coming back here, and I'm going to right-click on the column because I want to organize the columns, and I want to find the comments because remember I added comments. So here's comments. Add that. Let's get rid of some of these things here. Thrust to weight ratio, we'll get rid of. Engine diameters I don't care about. Recommended delay I do care about. Actually, let's turn this into optimal delay because that will be a more precise number. Maximum altitude, altitude at deployment, I don't really care about that. Maximum velocity I don't care about. Okay, so here's my comments. And if I can expand this column out. So this is the 6 fins that are the same size. This was the original 3 fins. I can't go back, unfortunately, add a comment later. I wish I could. Okay. I think, let's see, is there a organized columns? I'm looking for mass at liftoff. If we had here, launch mass. Okay, I'm gonna move that one over here. Let's move the optimal delay over to here and expand our comments out. So at liftoff, the 3 fins, it did weigh less. It wasn't much. Okay. It should be a little bit more than that. I don't know what happened. Okay, so now let's change these fins to be smaller so that the static margin, and you can see the static margin in the 2D display is right here. And we want to get that to 1.12 or pretty close. So basically we're going to move the center of gravity back towards here, or the center of pressure forward to get it closer to the center of gravity, so they're closer together. And I will, there's a number of ways to do this. Let's make the fin smaller. So go to the rocket design components, go to the custom fins, and we're going to go to the plan points, and we're going to adjust the size again. So here's the size originally, and remember, we're looking at this number right here. We want to get it to about 1.12. So I'm going to take this point here and drag it down, take that point, drag it down. So basically I'm making the fins, less, span-wise distance. And we're at 1.63. I'm trying to change as little as possible because it's really not an apples to apples comparison because we're changing the fin size. Okay, so that's like really close right there. 1.9. .18. I can zoom in and move it. There we go, I got it perfect. Okay, so the fins change size, and click OK. So now the distance between the center of gravity, which is this, and the center of pressure, which is this, is 1.12 times the diameter of the tube, which is what we had it for that first simulation that we ran. And why did it move my column? Okay, so we're going to run the simulation again. And 6 fins that are smaller in size to the original 3 fins. So let's flight profile and launch it. And we can kind of cheat again by looking at the summary screen. So this did not go as high as that. And our weight is like really close. So let's just look at it, see if it's going to go outside of the cone. Remember, this is a cone. And nope, we're inside the cone. We're always looking at the apogee point inside the cone. That's really all that matters. It can do like, as long as it's inside the cone, I'm okay with the flight. Although if it went woo, I'd probably say, no, not quite stable. Okay, so this rocket's going to come down and it's going to land about 553 feet downrange, and click cancel. So we got to we're comparing this one versus this one. Oops. And so the 3-fin one went higher than the 6-fin one. And both the weights are pretty close. I mean, they're less than 0.5 gram apart, which tells me that what's the difference between the 3-fin and the 6-fin? It's probably just the drag. just the drag of the fins alone is going to make the rocket fly not quite as high. It's close, but not the same. We're comparing 732 feet versus 696 feet. So which one is better? Define better. If better means which one went higher, then the 3-fin. If better means which one flew straighter, we didn't really look at the trajectory, but you could probably look at that and see which one looked like it was going straighter. It's typically likely that the 6-fin will go straighter. Yeah. Excuse me. Okay. So hopefully, Mark, that answers your question about he was comparing in designing a rocket and trying to decide if 3 bigger fins is better or worse than 6 smaller fins. So, like I said, you have to define better. What does better mean to you? Okay, so let's see. Two Explorers said, asked this last week. I have an Estes Super Neon, discontinued now, but I have one. Found a RockSim file, but it does not have the balsa fins on the tubular fins. Doesn't want to seem to fly. Super Neon XL. Okay, so let's go to the internet and see if we can find a Super Neon XL. So I'm going to do a search bar and a Super Neon Rocket Kit RockSim file. Let's see if Bing can find him. So we have a Super Neon RockSim design file from rocketreviews.com. Let's go there. Okay, it says download the Estes Super Neon. I'm going to click download and it put it into my downloads folder. So I'm just going to kind of hide that for right now. Go to my downloads folder, open my downloads, and here it is. So here's the Estes Super Neon, and I'm going to open it. And to open it, I just drag it onto RockSim. And it says, do I want to save the changes to this old design? And I'm going to say no. Okay, so here is a weird design that somebody created. And let's look at it in 3D. See if it looks any better or worse. Okay, so we got some fins, and they're not quite attached to the tubes. Let me see. I do not know particularly what the Super Neon looks like. It said it didn't find anything for that. It's just Super Neon. Let's do a Super Neon Rocket Kit image. Look at this. What does Bing call this thing? They're I forget what they call it, but man, it's already finding things about it. What I'm looking for is an image. And let's hit the return key and see what comes back as an image. Okay, so that's the best image that I can find. So it has fins on the outside of the fins, or on the outside of the tubes. And I'm not sure if it says Super Neon. I don't know if you can see that. Okay, I just wanted to know what the heck the Super Neon looked like. So those fins are not quite the right shape. So we would have to correct our file first. So go to the rocket design components, click on that. And it's got these fins here. And we have a pod. We have 1, 2, 3, 4, 5, 6 pods attached to the fins. Interesting. And each of these pods has a fin, and the fin weighs 0.606 grams. That's kind of like really lightweight. Let's delete these because we're going to have to correct this. So I'm going to select them one at a time and hit delete. Say yes, delete it. And this is going to take forever because my computer's running slow when I'm streaming. Delete. Yes. Delete this one. Yes. Delete that one. Say yes. Okay, so now we're down to one fin right there. If you can see that. So we need to make that look kind of like the other one. So basically, the rocket, just kind of looking at it otherwise, we have a nose cone, a body tube, and then we have these tube fins, which is the right way to do it. We have the launch lug, and then we have all the internal stuff, and then we have this body tube right there, which is the engine mount. I always like to change the name so that I know what I'm looking at. So I'm going to call this the engine mount. Click OK. Okay, and then we have a parachute and then the pod with the fin. So here's one pod. So a pod, and this goes to the other question that To Explore wrote. Was it you? Yes. Yes? No. Yes. Can you save a pod? So a pod is a collection of parts, but a pod that's different from a subassembly is a pod is on the outside of the rocket, subassembly is on the inside. But you can't save a pod by itself. So I'm going to try to open this pod. And I want to edit the pod. So the location of the pod is right there. Let me see where it is. If I look at it at the base view. Okay, so it's on the fin, or it's on the side of the tube. Right there. So that's a good spot for it. I'm okay with that. And what we're going to do is attach a fin to that pod. So I'm just checking the pod here. It says the pod can be ejected. No, we don't want to eject it, and we don't want to mark it as ejected. So that's fine. So a pod doesn't have any weight because it's just a collection of parts. And we're going to add parts to it, and the part that we're adding is a fin. So, and this is a custom fin. And right now it's the shape of a triangle. So we're going to modify that. So we're going to go to the plan points. And here's my pod. And I got to look at my picture again. Okay, can I zoom this? Does that zoom in there? Yeah, I zoomed a little. Oops. What did I do? You found all kinds of rockets the same shape. Okay, so it looks kind of like it's got a short thing, probably about not quite 50% of the length of the tube, and then it extends outward. We're going to approximate it. We're not going to be perfect. Okay, so first, this fin location is, why is this the front of the fin back here when it should be attached there? Is there anything that tells me fin count? It's made out of balsa wood. Don't want anything from the database. This is interesting. Why is this fin way back here when it should be up here? I don't know. So, anyway, we're going to make this bigger. To make it bigger, I'm going to zoom out a little bit. Okay, I'm going to grab that point. I'm going to move it here. I'm going to grab another point, move it there. I'm going to take this point, and I'm going to move it there. Okay, so now it's a little small, and it moved it even further back. Why did it do that? Why, oh why? But we need to make it bigger. I think the span is getting close to where we want, but the oops, I grabbed the wrong point. Undo the last, this point right here, and I want to make this one kind of like there. I don't think it's quite long enough yet. I'm just kind of approximating the shape here. Okay, so now my problem is, why is it not in the right spot? That's interesting. Plant points. Well, let's see if we can adjust it in the pod location. It's just kind of like too high. Okay, so we're going to take this and we're going to slide it forward. So why is it, this should have been like right at the center of that. Oh, maybe it's this. Location 0 from the base. And it's interesting. Where's that pod attached? This pod is attached to the body tube. Interesting. So let's move it forward. Why am I looking at the side of it? This is weird. It kind of flipped things on me. That is weird. Yeah, it's going to be close enough. Let's look at it from the top view. This is moving around on me. There's something going on. Something going on with pods. This shouldn't be happening. It's something I'm going to have to ask the programmer about. Say, what's going on with my pods? I'm currently using RockSim version 11. So this is a version that you don't have yet. I thought we were done with the bugs. But in the 3D, it's just too far up. And I can adjust that here. See, it's a little bit off the tube right now. So that's much better. Okay. And it's just too far back, but other than that, see, in 2D it just looks different. It looks further back. Anyway, so now that you have a pod, now we're going to duplicate this. So I'm going to do a highlight it, go right click on it, and then say copy. And then we need to paste it onto that tube. Paste. Ooh, look at that, it changed it. What the heck? Okay, so then we're going to go to open the pod. Man, it changed my shape. Radial position, let's make it 60 degrees. Let's look at it from the back. Yeah, it's in the right spot. I think I needed to go 60 degrees should have been it. It's not 120. 90. That's interesting. At 90 degrees, it's right. And then you got to do it. You got to do it multiple times. But anyway, we're not going to have time for that because we're almost out of time here. But then you would run a simulation. So again, choose prepare for launch. Choose engine. Let's go with an Estes. Manufacturer code Estes C6 5. Okay. Again, before we're ejecting at maximum ejection delay, simulation controls we leave alone. Starting state, it's launching straight up. And again, our conditions are 700 feet above sea level, 59 degrees Fahrenheit with a wind speed of 8 miles an hour. And hit flight profile, let's see if it goes. And it went. Oops, it left my comment in there. I forgot to clear the comment. All right, and the rocket's taking off, and it's going up, and it's coming back down. Okay, so it went 705 feet on the C65. And basically, I only had 2 external fins, but with the tube fins, the rocket was stable enough. So his question to Explorer, I found a RockSim file, but does not have the balsa fin on the tubular fins. Doesn't seem to want to fly. If it doesn't seem to want to fly, do what I did and modify the design. Don't be afraid to modify it. You can always download it again and start over again. Don't be afraid to try things. Even if it doesn't work, like what you saw me do. Mark Sell says, you've given me good ideas about how to do the 3 fins versus 6 fins. To Explore says that file is different from mine, which might be the reason why yours is not working. Can a subassembly be attached to a pod? And let's see. That's something I've never thought about before. So here's a pod, and the subassembly button is not selectable. So no. That was easy to find out. You cannot attach a subassembly to a pod. But you can attach a tube So if I put a tube in there to a pod, body tube, right there. And I don't know, I'll select this tube. So we added a tube. And now we select the tube and we can attach the subassembly to that tube. So you can do it. You can get a subassembly into a pod, but you can't attach it directly to a pod because there's an ownership role there. Johan says he's late again. Johan, show up on time. Although this week you're excused because I forgot to schedule it, so you probably didn't get a notification. He says he might have to design an airplane type soon. It inspires me. That's good. If the pod is attached to the body tube rather than a tube fin, the radio would be accurate. This pod is attached to the body tube. So it's attached up here. If it was indented one level, see, we can't attach a pod because it's not lit up when we highlight the tube fins. So that tells me that this pod right here is attached to that body tube. And I'm not sure why it's not attaching correctly. Oh, Mark Sell is right. He says you started first at 30 degrees, so add 60 more and you get 90. He's smart. Mark Sell's smart. You better listen to him. Okay. And 2 Explorer says, great, better than I got. I like the comments on the flight screen too. Yes. Okay, so we are out of time, and I can only go till 3 o'clock today because I do have to go pick up my daughter from the airport. So I can't take any more questions. But you guys have been great. Had a lot of great questions. I should be back next week. I'm not going anywhere anytime soon. The next time we might pause on Easter weekend, Good Friday. I think I'm going to be out of touch. So the Good Friday, Easter weekend will be off. I think that's the last weekend in March. But I think we got 2 RockSim Lives ahead of that, so we'll be here next week. So Alfred Indy says, Mark Sell gets a star next to his name. I agree with that. Where's my screen here? Okay. Outro. There's my outro. Okay, there I am. So again, thank you for coming. You guys have been great. Spread the word. Let your friends know. We are trying to get RockSim 11 out. I am desperately trying to get it out because it's been in production for so long. And I know you guys have been waiting. So thanks again. I'm going to give you a countdown and we'll get out of here. So in 5, 4, 3, 2, 1, go out and launch something.